Good morning or good afternoon. Today we'll be recording a video on quizzette 626 for highly accelerated. Please make sure you write your last name, comma, your first name, today's date, which I believe is March 5th, and your class color. Today I'll say that I am green or something. All right, so number 1 says a parallelogram has a base of 12 centimeters and a height of 8 centimeters. What is the area of the parallelogram? So parallelogram just means that you have two sides that are opposite of each other and they're parallel, and then another set of sides that are also parallel. So the way you would indicate that is this side is parallel to this side, and these opposite angles are also parallel to each other. So they're kind of like arrows. That's just constructing a parallelogram. It says we have a base of 12 centimeters, and a height of 8 centimeters. So we could say that the height is 8 centimeters. What is the area of a parallelogram? Now, you can use your notes, or you can just know that the area of a parallelogram is base times height. So the area is base times height of a parallelogram. So area equals 12 times 8. So the area would be 96 centimeters squared. Number 2 says, which point on the coordinate plane is a reflection of the point A across the y-axis? So I know this seems a little foreign, but the key word right here is reflection. So it's kind of like a mirror, and it's telling you what to do it in what terms it wants you to look at it. So the y-axis is right here. We're looking at point A, which is right here. So if we're reflecting it, it's like if you were folding the axis in half by the y-axis. So if we were to grab this paper and we were to actually physically fold it, where would A be reflected upon the y-axis? It looks like it would be at point N. So you would say point N is the reflection of point A across the y-axis. Now, just as a little, I guess, extra credit, but I'm not actually giving you extra credit. I just want to, just like as an extra point, if they asked you to reflect it upon the x-axis, it's as if you were getting your paper and you were folding it right here at this line. And if you were folding it right there at the x-axis, A would actually be reflected to point P. Point P. Just a little side note. Number 3 says, Juan has a box that is 3 feet long, 2 feet wide, 3 feet high. What is the volume of the box? So volume, another word for volume is, in a sense, it's kind of like area, but in 3D. So area in 3D, or you can think of liquid. So let's say that you're talking about a rectangle or a square. That's a 2-dimensional object. But watch closely how I make this to a 3-dimensional object. So this square, I'm going to write another square or draw another square on top of it. And then I'm just going to connect their sides. So that's a 3-dimensional object. That, when we're trying to find the quote-unquote area, we're actually looking for the volume. We're trying to see how much space is inside of this 3-dimensional object. Okay, now a rectangle in the same way, you can just draw a rectangle on top and then just connect those corners. So that rectangle is now a rectangular prism. So in this case, or you can call it a box. Juan has a box, so let's draw a box. Okay, so I'm going to draw a rectangle, then another rectangle.